Okay. Hello everyone and welcome to reactions of alkanes and alkenes. So we've been doing this in class, as you know, and we're just going to continue off with what we have done. Here I have our poster. So you guys, I'm going to try and keep following on with what looks like a poster. So you have a double A4 page inside your book with reactions of alkanes and alkenes. So we remember that alkanes undergo two main types of reactions, okay? And only one of them we've spoken about so far, which is, call it out, combustion. Okay, so combustion we've spoken about a little bit, combustion, and you had a little bit of homework where you had to balance different combustion reactions, and then we have substitution. Okay, so that's what you should have so far. Now let's have a look at combustion again. Okay, so you remember when we did our role play and we had the two oxygen atoms and then we had a methane molecule, okay? And then when we light it with a splint, we break the bonds in the reactants, and then straight away they become products. And we end up with two water molecules and one carbon dioxide molecule. Okay? So this is just the example that we did just now summarized. So we have one methane, two oxygens, one carbon dioxide, two waters. So let's start balancing the equations for these hydrocarbons that we gave you for homework. Now, to balance equations, there are a few simple rules. So rules for balancing equations. There's just a couple of rules. First rule, make sure that, so I want you to write these in your book, make sure that you have the same number of each atom on each side of the equation. Okay? Next rule. Rule number 2. Write down the states of each reactant and product and put in brackets, brackets as a subscript. Okay? Put in brackets as a subscript. And separate the reactants from the products using an arrow, like this. Okay, so there are rules for balancing equations. Okay, you might have to pause the video so that students can write this down. So octane we have here, which we know the formula for octane is C8, H, and we've got an ane, so no double bonds, so it is 2N is 16 plus 2 is 18. Plus oxygen produces CO2, we know that's horrible, got our greenhouse gas emission, and water. If only we could produce more water from this reaction. Okay, now importantly are the states, And because we heat up the solution when we light the splint, we actually convert everything into the gaseous phase. So octane's usually a liquid, but in combustion, it's a gas. And so is water. Now, let's balance. Now, I'm just going to write balancing in a different colour. So, to balance, I follow some simple steps. Okay? Now, first step, okay, oops, 1, balance for the number of C's. Okay, so balancing for the number of C's, we have 8 on this side and we have 1 on this side. 8 versus 1. So we need to add an 8 here to say that we have 8 C's. Next, I balance for the number of H's. Balance for the number of H's. So here we have 18, and here we only have 2. We have 18 H's here, and we have 2 here. So 2 times 9 is 18, so we need to put a 9 here. Okay. And then step 3 is when I do the oxygens, just because in the products, the oxygens are found in 2 molecules. Okay, so we've got 8, well, sorry, on this side we have 2 only. And on this side we have 9 plus 16, which is 25. Okay, so 25. Now, how can we convert this into a 25? Let's have a look. 2 times 12.5 is 25. Okay. The only thing is, we don't like using decimal points to balance equations, so that's simple to change it. All we have to do is convert everything, we have to times everything by 2. So if I go here, 1 times 2 is 2, 12.5 it should say, times 2 is 25, 9 times 2, 8 times 2 is 16, and 9 times 2 is 18. So we have successfully balanced for octane. Now let's go for pentane. C's, 5, number of H's, 12 on that side, so we need a 6. Now number of O's, we have 10 plus 6, 16, so 8. Nice and simple. Nonane. We can fit nonane here. So nonane, let's go. We have an alkane, so it's CH, C9, H, 2 times 9, 18, plus 2, 20. We know that everything's in the gaseous state. Just lost my pointer. Here we go. Balance for the number of C's. We have 9 on that side, so we need 9 on this side. Number of H's, got 20, so we need 10. And number of O's, 2 times 9 plus 10 is 28. So half of 28 is 14. Done. So methane we have done, and ethane, now methane we've done. Okay, so combustion reactions. What I want you guys to do is, if you haven't already, writing it on and put an example, like one that we've already done. And then I want you to write everything in gas state. Everything is in the gaseous state. Okay, just so you've got a note there and you remember that. Okay, so combustion reactions. We've done the methane bubbles demo. So the most important significant reaction in our society, of alkanes in our society is combustion. Here you can see a refinery, and that's combusting different alkanes, probably coal actually, but to produce carbon dioxide and water as the byproducts, which go into our atmosphere. Okay, they have oxygen as a reactant and H2O and CO2 as products. So what I want you guys to do is pretend that you're in the environmental minister of Williamstown and you're deciding if Hot Wings should use ethane or propane to fuel their cooking of barbecue chickens. Okay? You want to see which is better off for the environment. You need to write two balanced equations to determine which hydrocarbon gas produces less carbon dioxide. Okay? So pause the video now and let the students try and answer that. Alright, so I hope that you have these two equations as the ones that you've worked out as your combustion reactions. Okay, so we have 2 molecules of ethane being converted into 4 carbon dioxide molecules. We then have 1 molecule of propane being converted into 3 carbon dioxide molecules. The ratio of our reactant to product to carbon dioxide in this equation is 1 to 3, and in the top one it's actually 1 to 2. Okay, because remember that it's a ratio. So for 1 carbon dioxide molecule, 1 propane molecule, we release 3 carbon dioxides. But for 2 ethane, so 1 ethane would produce 2 because 2 produces 4. So this one is actually more environmentally friendly, the top one. Yay! So now we're going to turn to substitution reactions. So that should be your second type of alkane reaction. So reactions with bromine. This is just to remind you because it's been a while since we actually did that bromine reaction. When we reacted it with the alkene, if you can remember, the color changed from red or urine color to clear. But when we reacted it with the alkane, red remained red, or there was no color change. No color. Why did I spell color like that? No color change. Okay? So bromine, I'll show you what bromine looks like. So bromine actually looks like this by itself. It looks red. And we know that bromine is in group. It's going to have 7 electrons in its outer shell. It's not happy like that. 1, 2, 3, 4, 5, 6, 7. It's actually going to pair with another bromine. Okay. 6. To have a single, oops, it's totally wrong, a single covalent bond. Okay, and it's going to be Br2. And this Br2 is the red color that we were talking about. Okay, this is red. Bromine by itself is like bromine, single bromine, or bromine connected to carbons, bromoethane, is colorless. So this should be a clue as to what is happening here. So, examples of substitution reactions. Chlorine is also a halogen, so it'll exist as it will have one single bond, covalent bond, or it will exist as a Cl2. Okay, and we remember that chlorine, should have actually drawn it in that color, but chlorine is actually a green color. Okay, so it exists as a very toxic gas. Now, if we react it in the dark with ethane, there is no color change, no reaction. But if we react it in UV light with ethene, so this is no color change, and chlorine still exists like this, okay, and ethene has been untouched. But this actually, if we react it with light, it actually reacts and it goes colorless. Okay, it actually goes colorless. Now, if we react bromine in light, bromine goes from red to colorless as well. So it shows that these two ones, this and this, have reacted. Okay, now I want you to talk to the person next to you. Give students about 2 minutes to do this and discuss these findings. What do you think are the conditions needed to get a halogen to react with an alkane? Okay. Substitution reactions. So I want you to go back to your sheet, and what I want you to do is write down the definition, which we're about to go through, and an example, which we're also about to go through. Okay. So, substitution reaction involves the replacement of an atom by another atom or group of atoms. But in this case, let's say we have ethane and we are reacting it with chlorine. So let's do chlorine in a different color. Single bond Cl. What happens is one of these hydrogens is removed and this Cl comes and replaces it. Okay, so let's do that. Rub out one of these H's and one of those Cl's apparently, and place the Cl here, and the H will bond, with the Cl to form hydrochloric acid, or HCl. So we have, what's this product? Chloroethane. Alkanes are stable, but when they are in the presence of UV light, or if we heated it up on the Bunsen burner, okay, we would get a substitution reaction. This is the way you can draw out the substitution reaction. That can be your example. Okay? Now, let's talk about reactions of alkenes. What I want you to do is take a couple of minutes to write down what you think alkenes are soluble in. Are they soluble in water? So, they're soluble in non-polar solvents such as oil. Do you think that alkanes are more reactive than alkenes, or vice versa? Give students a minute to try and answer this using their idea of what happened with bromine in the fume hood. So if bromine reacts with the alkenes but it doesn't react with the alkanes, it says something about the reactivity, the higher reactivity of alkenes. Okay, so it just so happens that the double bond is a more reactive site. It's got more electrons in there, so it's less stable than a single bond. So it will in fact undergo more reactions. Okay. The high electron density in the double bond makes them a bit more reactive than alkenes. Okay, now they can undergo two main reactions, combustion or addition reactions, including addition polymerization. Very fancy sounding word. Okay, so let's add that to our poster. Okay, here we've got, let's go in red, alkenes. We have two types of reactions. We have combustion and addition. Okay, so we're going to skip combustion because we've already covered it with alkanes. Exact same thing. Okay, you have the oxygen as a reactant and carbon dioxide and water as the product. So let's talk about the addition reaction of alkenes. Okay, we saw an example of this when bromine reacted with ethene, or with cyclohexane. Okay, so let's have a look at what happens, and this is quite complicated, so listen up. So we've got ethene down here, and we have bromine. Bromine is red coloured. Okay, it reflects light and in the red coloured wavelength, and that's what we see. So now, because the double bond is very reactive, sometimes it breaks. Sometimes the electrons move and they break, right? They break and each carbon atom is left with one unpaired electron. I'll tell you what, it's not happy like this. This is actually called a free radical, and they're very nasty things because they can give you cancer. Free radical, basically very reactive, will do anything to get an extra electron or get another bond. So if bromine's around, bromine will have no choice but to split apart and add to ethene to become 1, 2 dibromoethane. So we'll write down the product 1, 2 dibromoethane. Okay. The other reactant is normally a halogen. Reactions don't normally need a catalyst, and one product is made. Notice that no HBr is made, or HCl, if it was reacting with chlorine. It's just one product. So under your definition, I want you to write addition reactions are reactions in which new atoms are added to the compound, and I want you to have this as your example. Okay. We have some other examples of addition reactions, and we're going to go through this in year 12 again, but it's good if you become familiar with it early. So ethene can react with bromine to, as we said before, to form 1, 2 dibromoethane. Ethene can also react with hydrogen in the presence of a catalyst to produce ethane. Ethene can also react with steam, but have a look at the reaction conditions that are needed for that to occur. I don't know if you can see that. A H3PO4 and a catalyst at 300 degrees Celsius. So it's pretty specific reaction conditions. So I want you to write those down as other examples. Now the final thing we're going to talk about is addition polymerization. So addition polymerization. Let's say that we have an ethene molecule. We have another ethene molecule and a final ethene molecule. Let's say we've got 3. Randomly, we might get the bonds breaking to form 3 separate free radicals. Just might happen sporadically. The bond just breaks. See how the electrons initially were bonded together, but they break. We can actually get this case where this guy sees this straight away, and he sees him as well. He sees him, and he sees him. And what happens is we can end up with a case where they all bond together to form a long chain made out of many monomers. Now this is called polyethene. Even though it's an alkane now because there's no double bonds, it's named after the monomer from which it was produced, which is ethene. And you'll be pleasantly surprised to find out that polyethene is actually the polymer that's in Glad wrap. So, where do I want you to put addition polymerization? Just going back to the poster. I want you to put it under an example of addition, right? You should have addition. Okay, and we'll get to this side in a minute. So this side will be what we've just done. But let's go addition polymerization. Whoops. Addition polymerization. And we have a good definition. And then we have a good example. All right. So in some cases, we can have addition reactions where they form polymers. The polymer is named after the monomer from which it's formed. They require a catalyst. Okay? Catalyst is not so important in year 11, but it definitely is in year 12. It's something that speeds up a reaction. So here we have ethene converting into polyethene. These are all taken from your book. Another example is styrene turning into polystyrene. So those foam cups. And another example is vinyl chloride turning into polyvinyl chloride, the thing that we make old records and such with. Okay, so what you should have in your posters so far is reactions, alkanes, alkenes. Under alkanes we have combustion, substitution. Alkenes we have combustion and addition. Addition we have addition of hydrogen, water, or halogen. And under addition we have polymerization as well. Now, I want you to hand out the loop game so that students can revise what they've learned. And then for the rest of the lesson, moving on to chapter questions for chapter 8 and any worksheets that they need to finish.